Hello everyone, welcome to this amazing channel of Infinity Learn by Sri Chaitanya. I am your host and host for the subject of chemistry, and you all call me AV. And I welcome you all for the paper discussion of your LTC MPL chemistry weekend test 18. Guys, those who are giving this particular test, you can just go to the solution. Both those who are subscribing our channel Infinity Learn by Sri Chaitanya and a part of this family, I'll recommend you guys keep please stop the video whenever a new question comes, answer it and then move ahead. Okay, so yes guys, let's not waste much time and quickly start the discussion. So in LTC MPL chemistry weekend test 18, the first question that came was statement 1, lanthanide element. Okay, lanthanide element with the largest atomic size is U. Okay, that is certainly true. Zirconium and hafnium has nearly same atomic radii. That is also due to what? LC, that is lanthanide contraction. So we'll go with option number 1 as the right answer. Okay, 52. The correct statement among the followings are: actinide shows variable oxidation state. True. Highest oxidation state shown by actinides in their compound is +7. True, where the lowest is +3. All actinides are synthetic elements. That is false. All actinides are not synthetic elements. As a matter of fact, mostly from 1995 to 103, all are what? All are what? Synthetic. But before that, they are non-synthetic. Okay, so A and B is right option. So we'll go with option number 3. Okay. 53. Which one of the following is anionic? That means negative charge. Homo means same. Lactic means ligand. Okay, so anionic, same ligand. Okay, so this is neutral ligand, neutral ligand, neutral ligand, and cyanide is anionic, and all are same. So we'll go with option number 4. That is the right answer. 54. The coordination number that is Cn and the oxidation state of the element E in the complex. So it is E, En, twice, C2, O4 and NO2 are respectively. So this is bidentate. This is also bidentate. So total there are 3 bidentate. So 3 into 2. So coordination number goes to 6. So coordination number is how much? 6. Right? We don't know this thing. This is a neutral ligand, whereas this is an oxalato ion, that is -2. This is -1. So X -3 equal to 0, that is X equal to +3. So oxidation state or oxidation number is equal to what? +3. So 6 and +3. 6 and +3 goes to option number 4. That will be the best answer. 55. The complex NiCO4 is homoleptic and homonuclear because only one nickel ion is there. So homonuclear or mononuclear, not homonuclear, mononuclear, single nickel ion. Okay. So central metal atom is 1, so it is mononuclear. 56. Which of the following is an hexadentate? Famous example, EDTA, hexadentate. Okay. So best option will go with option number 4. 56. Option number 4 is the best answer. 57. IUP is the name of the complex. Okay, so this complex is of type complex cation and complex anion, and you know that first preference is given to cation and the name is given to what? Anion. So in the first we'll be doing the naming of complex cation, then we'll be naming complex anion. So let us start. Complex cation, the preference is given to ligand. Ligand is amine and that is 2 times. So it is diamine. So diamine, diamido, gone. Not required. And diamine, this can be the answer. Okay, diamine silver with 1 oxidation number will be what? +1. Okay, so diamine silver 1, all are same. Then comes the negative part. Okay, then comes the negative complex anion, right? Or complex anion. Again, this is given preference, that is dicyanide. That means 57. Option number 4 is also gone, right? And argentate. It has to be what? Argentate, because in anion what we take is their Latin name. So it is argentate. So that means this is also gone. So we'll go with option number 1. So 57, option number 1 will be the best answer. 58. 1 mole of a yellow octahedral chromium complex. Octahedral chromium complex means its coordination number has to be 6. Okay. Reacts with excess of AgNO3 solution, weight of precipitate formed. So here in COCl3 dot XNH3. This X is 6 and this complex can be written as cobalt NH3, sorry NH, extremely sorry, wait, this is also cobalt, so this is cobalt NH3 6 times and Cl3. So this all Cl3 is what, ionizable, and once it is treated with AgNO3 solution in excess, it will give you what, 3 AgCl as a precipitate. Okay, so what is the molecular weight of AgCl? It is 108 plus 35.5, right? So it is 143.5. So 3 into 143.5. Okay, 143.5. Okay, so it is like 15 into 3 is 45. So around 45. The only option is 430. Okay, so 58. Option number 3 will be the best answer. 59. For the molecule MA4, to exhibit linkage isomerism, ligand must be, okay. For linkage isomer, you should know that ambidentate. Okay, ambidentate ligand is required. So in all the options, the ambidentate ligand is ligand is SCN-1. 60. The following complex does not show optical isomerism, but has 3 stereoisomerism. ABCD are monodentate ligands but not ambidentate. So tetrahedral MA4, it cannot show geometrical isomerism, and certainly it cannot show stereoisomerism as well. MA4, because all are same. Square planar MABCD, yes, it can show, right? The square planar, so ABCD. Okay, another it can show you this thing, ACBD. Another it can show you one more, that is ADBC. Okay, they all are GI, but no one is optically active, no optical activity, right? So this will be the best answer. Okay, and if you remember, it is suggested that please try to remember in which of the complexes optical isomerisms are seen. If you remember this thing, MA2, B2, C2, all cis form, okay, all cis forms is optically active. Okay, clear? And over here, there are only 2 possible isomerism that can be found, or 2 possible geometrical isomerism, and both are what, optically active. So I'll go with option number 1. Okay, in which they form stereoisomerism but they do not show optical isomerism. So 60, option number 2 will be the best one. 61. According to VBT, the half-filled orbitals of central atom ion only can involve in hybridization. That is false. According to VBT, rearrangement of electron against Hund's rule cannot occur in central metal ion. That is also false. Okay, because in the presence of strong field ligand and weak field ligand, okay, it will not obey Hund's rule. So both statements are wrong. So we'll go with option number 4. Okay. 62. The central metal ion in the complex which contain least number of unpaired electron in an octahedral complex with weak field ligands. Okay, it's a weak field ligand. Okay, so weak field ligand means what? There is no excitation of electron. It is normal electronic configuration, and in normal electronic configuration, we know that Cu2 plus will have electronic configuration as 3d9, and that means it has only one unpaired electron. Okay, so we'll go with option number 3. Okay. 63. Wood's reaction of methyl iodide yields the organic compound X. So methyl iodide undergoes Wood's reaction to give you CH3, that is ethane, X. So which of the following reaction also yield X? So ethyl chloride, magnesium dry ether, you will get ethyl magnesium chloride, that is Grignard's reagent. So this is not the answer. Ethyl chloride with the reducing agent will give you ethane. That will be the right answer. This is Williamson synthesis. Ether is formed, and over here it is ethine that is going to form. Okay, so option number 2 is the best answer. Okay, option number 2 is the what best answer. Which one of the following alkenes shows optical isomerism? Shows optical isomerism. So let us try to draw pent 3-methyl pent 1-ene. So pent 1-ene. So it is 3-methyl pent 1-ene, and you can see in the first structure itself I can see a chirality, and since there is only one chiral center, this has to be the answer. Okay, so let's check. Yes, 64, option number 1 is the answer. 65. Acha, one more thing before I come to 65. For 64, in the same way you can just keep on drawing, or you can just keep on imagining the structure, you will get the answer. But fortunately in the structure number 1 itself we got a chiral carbon. That's why I'm going with 64, option number 1. 65. During the preparation of ethane by Clove's electrolysis method using inert electron, the pH of the electrode increases. Why it increases? Okay, I am saying pH of the electrode increases. Why it increases? Due to the formation of base at cathode. Okay, so it increases. So we'll go with option number 1. Okay. 66. Elimination reaction of 2-bromopentane to form pent-2-ene is beta elimination. True. Follows Zaitsev rule or Zaitsev rule. True. Dehydrohalogenation. True. Dehydration. False. So A, B, C are right. So A, B, C, A, B, C. Option number 4 is the best answer. Okay. 67. Alcoholic KOH. Okay, so how many carbons are there? 1, 2, 3, 4. So A will be, okay, HBr, that means B will be this, and C alcoholic KOH, this. Okay, the following compound is the positional isomer but not the chain isomer of C. Positional isomerism. This is but2-ene, hence but1 will be the position isomer, not the chain isomerism. Okay, so 67, option number 1 will be the best one. 68. Ethylene can be obtained by dehydration of which of the following compound with concentrated H2SO4? Ethylene, ethanol. Got the answer. 69. CH2 double bond CH2 gives you A in the ethene reacts with bromine in the presence of CCl4. That means bromine, it undergoes anti-addition. Okay, then zinc in alcohol. Okay, that means again reducing agent. That means CH2 double bond CH2 is formed again. NaNH2, it's a strong base. It will give you CH triple bond CH. So the best answer B is ethyne and C is ethene. So both B and C are alkenes, no. Alkynes, no. B is alkyne, yes. C is alkene, yes. Option number 3 is the best answer. 70. 2-butene on hydrogenation in presence of Lindlar catalyst. Lindlar's catalyst undergoes cis addition. 2-butene means cis-2-butene. Okay, Lindlar catalyst and partial reduction. That means butene will get converted to butene. That to cis form. So cis-butene will be the best answer. 71. Boiling point of cis-2-butene is higher than that of trans-2-butene. That is true. Why? Because if you'll see CH3, CH3, H, H. Dipole moment, dipole moment. That means the resultant dipole moment at bottom. If I talk about trans, okay, dipole moment, they cancel out each other. That means it has some dipole moment. That means some force of attraction is there, and hence boiling point increases. So yes, boiling point of cis-2-butene is higher than trans-2-butene, and the second statement itself justifies this thing. Dipole moment of cis-2-butene is higher than trans-2-butene, and hence both are true. 72. The correct decreasing order of hyperconjugated hydrogen atoms in the above 3 compounds are. So first of all, let us mark alpha carbon. So alpha, 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 alpha. So total 4, 6, 10 alpha hydrogen. Here alpha, alpha, 4 alpha hydrogen. Here alpha, alpha, alpha. So 2, 3, 7 alpha hydrogen. So the option is 1, 3, 2. 1, 3, 2. 1, 3, 2. Option number 3 is the best answer. Okay. 73. Which of the following shows least reactivity towards electrophilic addition reaction? Alkene, alkene, alkyne, alkene. I'll go with alkyne. Why? Because if you add this thing, okay, if you do electrophilic addition reaction, okay, if you'll do what? Electrophilic addition reaction. So suppose CH and you are adding this thing, right? That means what is going to happen? CH double bond CH2 with a positive charge, right? That means this electron is shifted over here and will take away this H plus ion, and hence what is formed? Vinyl carbocation. And since vinyl carbocation is highly unstable, that's why its electrophilic addition reaction is less, okay, or least reactive. Okay, so 73, option number 3 will be the best answer. X, Y, Z, R. So if you'll see this reaction, they all are addition of OH, that means hydration of alkyne, and hydration of alkyne is done in ACH, that is acid catalyzed hydration, or OMDM, that is oxymercuration, demercuration, or HBO, that is hydroboro oxidation. This is 1 degree alcohol, this is 2 degree alcohol, no arrangement, this is 3 degree alcohol. So for 1 degree alcohol, I'll go with hydroboration oxidation. This is oxymercuration and demercuration, and this is acid catalyzed hydration. So X is HBO, Y is OMDM, and Z is ACH. So all are acid hydration reactions. Okay, no acid hydration. X is what? X is hydroboration. Okay, so hydroboration. This is not the answer. This is not the answer. Hydroboration oxidation, oxymercuration, and acidic hydration. That will be the answer. Last one is acidic hydration. Not the right answer. We'll go with option number 3. 75. Which would be what would be the major product when propene reacts with HBr? So propene, CH3, CH double bond, CH2, HBr. In the presence of benzoyl peroxide, that means what? Anti-Markovnikov's rule. So you'll get CH3, CH2, CH2, Br. Br2, not the right answer. Not the right answer. Here it is going into Br is getting added to what? Second carbon atom in this case. Not the right answer. Okay, so this is not the right answer. It should be on the first carbon atom. That is option number 2. Okay. 76. 2-butene, KMnO4, alkaline, cold medium. That means glycol formation by Bayer's reagent. This is Bayer's reagent and hence glycol formation. Butene, KMnO4, acid, heat. That means carboxylic acid. Carboxylic acid formation, it will give you 2 moles of acetic acid. 2-butene, ozonolysis, it will give you aldehyde, 2 moles of aldehyde, that is acetaldehyde. So A is glycol, 2 and 3 are out of scope. B is ketone, B is carboxylic acid. So this is gone. 4th is the right answer. 77. An hydrocarbon X on reduction gives 2-methyl butane. On ozonolysis, it gives acetone as one of the products. So for making acetone, you need alkene like isobutylene type. Okay, it gives you butane, so this will be the structure. Okay, 2-methyl butane. Wait, 2-methyl butane. So this should be the answer. 2-methyl butane. So this can be the structure. The hydrocarbon is CH3. Only this has CH3 group, so I'll go with option number 2. 78. Molecular mass of alkene is 56. It gives same addition product with HBr in the presence and in the absence of peroxide. That means it is a non-terminal alkene or alkyne. Identify the incorrect statement. It is 56. If I take C4H8, 12 for the 48 and 56. So basically it consists of 4 carbon atom, and this is butene, non-terminal or symmetrical alkene, because addition of HBr in absence or presence of peroxide giving you the same product. That means no Markovnikovs and anti-Markovnikovs, and that is only possible when alkene is symmetrical. So this is the case, right? Ozonolysis gives you 2 moles of aldehyde, true. Shows geometrical isomerism, true. Acid hydration gives you 2 butanol, true. Oxidation of hot KMnO4 gives 2 moles of acetaldehyde, false. Hence the right answer. It will give you 2 moles of acetic acid. 79. Alkanes have low boiling point due to weak London dispersion forces. Order of boiling point is correctly represented as alkanes have low boiling point, that is true, due to weak London forces, and we know that weak London forces increases with the increase in molecular mass. So in the first case itself, if you will see, there is an increase in molecular mass, so this will be the correct order. Okay, and as branching keeps on increasing, its boiling point keeps on decreasing. Okay, so that will be the case. So order of boiling point is correctly represented in option number 1. CH4 when oxidizes in presence of copper at 523 Kelvin and 100 atmosphere, what has been formed is methanol. Okay, what has been formed is what? Methanol. The reactivity of hydrogen atoms attached to carbon atom in the halogenation of alkane is 3 degree, that is tertiary, secondary and primary. So tertiary, secondary, primary will go with option number 3. This is N-hexane treated with chromium oxide at 773 Kelvin at 10 to 20 atmosphere give you X. This is aromatization reaction and it has to be benzene. So right answer, it has to be benzene. Right answer is option number 2. 83. A mixture of camphor and NaCl is separated by, camphor is volatile whereas NaCl is not, so hence sublimation will be the best technique to separate. A very common adsorbent used in column chromatography, powdered charcoal, alumina, chalk, sodium carbonate. Alumina will be the best answer. The name of this thing is methyl cyanide, yes. Ethane nitrile, yes. Acetonitrile, yes. So we'll go with option number 4, all of this. Gadolinium belongs to 4F series, okay. Its atomic number is this, okay. Which of the following is correct electronic configuration of gadolinium? Please remember gadolinium, okay, it is one of the element, okay. Lanthanum, gadolinium and lutetium are the elements which does not show transfer of d orbital electron to f orbital. Okay, it does not show, that means d orbital will have 1 electron. Okay, so d orbital has 1 electron. It is not the case, so it has to be this. Okay, half-fill stability, gadolinium. Okay. Reason for the lanthanoid contraction is poor screening effect of f orbital, true. Statement 1. In the aqueous solution, compound of Ce plus 4 are good oxidizing agent. We know that basically what we say, lanthanides and basically lanthanides. Okay, lanthanide shows +3 oxidation state. Most stable is in +3 oxidation state, and Ce plus 4, that is cerium, will take up 1 electron to give you Ce3 plus. That means it undergoes reduction, and that's why it acts as a good oxidizing agent. So this is true. Initial member of lanthanides resemble aluminium in their chemical reactivity. That is also true. So we'll go with option number 1. Oh, sorry. Okay, so next question 88. In the aqueous solution, compounds of Ce plus 4, that is cerium plus 4, are good oxidizing agent. That is true. Why? Because this is the lanthanide, and lanthanide shows positive. Lanthanide shows most stable oxidation state as +3. So Ce plus 4 will take up 1 electron and undergoes reduction to give you what? Ce plus 3, which is a stable state, right? So it undergoes reduction and hence it is a good oxidizing agent. So true. Initial members of lanthanoids resembles calcium, not aluminium. It represents calcium in their chemical reactivity. The second one is false. So statement 1 is correct and statement 2 is incorrect. So we'll go with this. 88, option number 2 is the best answer. 89. The least oxidation state exhibited by an actinide element in its compound is +3. Okay, so we'll go with option number 2. 90. Which one of the following lanthanide element is steel hard with a melting point of 1623? Steel hard is samarium, that is Sm. So we'll go with 91. Okay. Now, the reason for the greater range of oxidation state in actinides is attributed to this. That is 5F, 6D and 7F subshells have comparable energies. Due to they have comparable energies, they have variable oxidation state. So we'll go with 91. Option number 2 will be the best answer. Okay. Now, talking about 92, the actinide element which does not contain 5F orbital. Okay, we are talking about actinide, and thorium is that element which does not contain F electron. Okay, clear? And if you remember its electronic configuration, it is 7s2 6d2 mostly. Yeah. 93. Which of the following actinide ion is having large size? So what we need to fixate is what? On the large side. So 93 will go with thorium plus 3. Okay. So which of the following actinide is having large side? It is thorium plus 3. So 93, option number 4 will be the best answer. Okay. 94. The systematic name of the following compound having the structure this is. Okay. This is a complex compound and its name has to be 1-methyl ethyl. So isopropyl, no. 2-methyl propyl, no. 1-methyl ethyl. So without doing entire IUPAC, if I do the IUPAC of this thing, 1-methyl ethyl, that will be the best answer. 95. The structure for the propane. Okay, the structure for propane 1,2,3 tricarboxylic acid is. Okay, 1,2,3 tricarboxylic acid. 1,2,3 tricarboxylic acid. 1, 2, 3. I can select this thing as the longest chain. Okay, there are 3 carboxylic acid as well. So we'll go with option number 1. So 95, option number 1 is the right answer. 96. The correct statement regarding the comparison of staggered and eclipse conformation of ethane is staggered and eclipse conformation. Eclipse conformation of ethane is more stable than staggered. Wrong. Staggered conformation of ethane is more stable than eclipse. That is true. Staggered conformation of ethane is less stable. Sorry, it is more stable. Eclipse conformation of ethane is more stable. No. So only place the staggered conformation of ethane is more stable than eclipse conformation. That we can go with the answer. 96 is option number 2. Okay. 97. The number of possible open chain, structural and conformational, that is what we say. They are expecting structural and stereo both. With the molecular formula C4H8. So C4H8, if you calculate its degree of unsaturation, it is 2. Sorry, C4H8 is 1. Sorry, its degree of unsaturation is what? 1. So this is butadiene, isobutylene, and will give you cis and trans. So 1, 2, 3, 4. 4 will be the best answer. Okay. 98. D-tartaric acid and mesotartaric acids are distereomers of each other. Okay. 99. Metamerism is not shown by the element which does not have more than it is not shown by monofunctional group. Okay. Diethylamine, it can show. Diethyl ether, it can show. Propion aldehyde, it cannot show because it is aldehyde, it has only single valency. So that will be the best answer. Which of the following compound is not possible with the formula C2H4O2? Let us see the option: hydroxy, ketone, carboxylic acid, ester and aldehyde. Even if you don't know the answer, even if you don't know the structure, you can directly mark ketone, because for ketone at least 3 carbon atom is required. So we'll go with option number 1. Okay. So yes guys, that was all the question that came in your LTC MPL Chemistry Weekend Test 18. I hope that I was successful enough into giving you a proper idea of each and every question and how to tackle it. Okay, if you still think that there is some ambiguity in the answer, please feel free to comment in the chat box so that we can give you the clarification. With this thing guys, thank you so very much for joining with me for this particular solution video. Take care guys. God bless you all. Keep smiling. We'll meet soon.